my second example, a cell phone carrier reported that the mean number of text messages per week in 2012 was 243 texts. A researcher claims that the amount has increased. A survey of 49 cell phone users from the same carrier had a weekly average of 250 text messages. Assume that sigma equals 22 texts, use the p-value method, and alpha equals 0.10. Okay, so again, I always like to start from the beginning, dissecting it. So a cell phone carrier recorded the mean number of text messages, the mean number. So I'm working with mu. Per week in 2012 was 243. So mu equals 243. Next sentence. A researcher claims, okay, so here's my claim, that the amount has increased. Now it just says the amount has increased, but the only thing we've discussed so far is averages, so that means my average has increased. Mu has increased. A survey of 49 cell phone users, so 49 is n, my sample size. A survey of 49 cell phone users from the same carrier had a weekly average of 250. We're in the sentence talking about those 49 users, assuming the carrier has more than 49 users. This is sample data. So when I talk about the average of 250, it's my X bar, my sample average. We're told to just go ahead and assume that sigma is 22, the population standard deviation, and use alpha of 0.10. So I've got all my data off to the side. I'm ready to fill in my boxes. First, I want to go ahead and find the null and alternate hypothesis. So mu has increased is where we started. Now, if you aren't sure what number goes after that, don't forget we've already stated that mu equals 243, and we have the same symbol and the same value in both null and the alternate hypothesis, so that means I have to have 243. So I've got my 243, whoops, which just disappeared. Okay, so it's back, and now we're ready to find our test statistic. Well, the 243 showed up again. Okay, so I'm using the z-score formula, x bar minus mu divided by sigma divided by the square root of n, because we're testing a claim about a mean, and we have a standard deviation known. So first thing I need to do is fill in the sample average of 250, subtract from the population mean of 243, divide, by sigma and the square root of the sample size to get 2.22727, etc. I'm going to go ahead and take 2 digits after the decimal to give me 2.23 for my test statistic. And I'm off to find the p-value. So remember, the p-value is the probability of the test statistic we got or worse. So we start with our test statistic of 2.23. I have a z-score, so I go to the edges of the z-table, and I find 0.9871. But I want the area to the right. I have a right-tailed test. My test statistic is positive, so it's on the right side of the normal table. So I need to do 1 minus the table value, and I get 0.0129, and I need to decide, do I double it? Well, we just said we have a right-tailed test, so we do not double that value. My p-value is 0.0129. Now I need to decide whether I reject or fail to reject H0, and if the p-value is less than alpha, I'll reject. So my p-value of 0.0129 compared to alpha of 0.10. Again, if you struggle comparing the numbers, you can always put zeros at the end of any number so that you're comparing 4-digit numbers. And since 129 is less than 1,000, I have a true statement and I will reject. But keep in mind, you write reject H0. And now I need to go for my final conclusion. So if my claim was H1 and I rejected H0, my final conclusion starts off, the sample data supports the claim that, and now I want a comprehensive sentence that clears up everything. Now up here it says claims that the amount has increased, but that's not clear enough. That's a little vague. So I need to mention that we're talking about text messages and what value they have increased from. So I will finish up my sentence. The sample data supports the claim that the mean number of text messages per week has increased from 243 messages. So we're focused that I'm talking about the mean, that it is increased, and that the original amount had been 243.